The question says, prove that the product of three consecutive positive integers is always divisible by 6. So here let a be any positive integer and b is equals to 6, because here always you see that it is given it we have to prove it is divisible by 6. So we will take b is equals to 6 and apply the Euclid's division lemma, and we know that Euclid's division lemma says that whenever a is being divided by b, then there lies integers q and r such that a equals to bq plus r. So hence here what we have taken, this b we have taken as 6. So we are dividing a by 6. So if you divide a by 6, then the remainder will be either 0, 1, 2, 3, 4 or 5. So it will be always less than 6. So it can be 0, 1, 2, 3 or 4 or 5. So according to the remainder, so the integer a can be written in the form of 6q or 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4 or even 6q plus 5. So these are the possible forms of writing the positive integer a. Now moving on to, in the question we have to prove that the product of three consecutive positive integers. So what do you mean by consecutive? Now see here. So when you talk about consecutive integers like 1, 2, 3, 3, 4, 5, 4, 5, 6. So they increase by 1. So here since we have taken our positive integer as a, so the next integer will be a plus 1 and the next one will be a plus 2, right? Like we have 3, 4, 5 or 4, 5, 6 in this way. So these are the consecutive integers, one after the other. Now here, so we have 6 types of forms for writing the positive integer a. So let's take the first one. So here we have taken let a equals to 6q. So when a equals to 6q, just you will write in place of the product here. The product is a into a plus 1 into a plus 2, that is the product. So in place of a, we have to put 6q. So here we see that in the first case, 6q can be written as 6 into q. Hence 6 can be taken out. So that means this total expression so can be written as 6 into something. So 6 into whatever it is written here. So 6 into something means that should be always divisible by 6, because that means it is a multiple of 6. 6 into something means it is multiple of 6. Since it is a multiple of 6, so it is divisible by 6. Moving on. Now a equals to 6q plus 1. So in place of a we use 6q plus 1. So 6q plus 1, after that 6q plus 2, 6q plus 3, as they are consecutive. Now here we can see 6q plus 2. See here 6q plus 2 can in that one 2 we have taken out common. So since we take 2 out common, we have 3q plus 1 inside the bracket. Now 6q plus 3, from here 3 we can take out common. Now finally what we have, 2 and 3 are the number part that we have taken out. So 6 into 6q plus 1, 3q plus 1 and 2q plus 1. So what we get again, 6 into something. So 2 into 3 is 6. So 6 into something means it is a multiple of 6. So multiple of 6, so we can say that the whole number will be divisible by 6. Similarly, we have to get it for the next form, that is 6q plus 2. The same way 6q plus 2, 6q plus 3, 6q plus 4. These are the consecutive ones. So here we have taken out 2 as common in the first case, 3 as common in the second case, and again 2 as common in the third case. So finally we get 12 outside. So 12 into 3q plus 1, 2q plus 1, 3q plus 2. Now we know that this number is always divisible by 6. Hence the product is also divisible by 6 because it is a multiple of 6. Since it is a multiple of 6, it is divisible by 6 also. Next, moving on like that, more 3 forms we have. Like that, we can show it for 6q plus 3, 6q plus 4 and 6q plus 5. So for 6q plus 3, we can take out as 3 as common, as you can see here, this one. So 6q plus 3 has been written like this, 6q plus 4 and 6q, there is no common here, so just leave it. So 3 2s are 6. So 6 into something, so again divisible by 6. Similarly for 6q plus 4, the same way, from here we can take out 2 as common, from here we have taken out 6 as common. So we have got 12. So 12 multiplied by 3q plus 2, 6q plus 5 and q plus 1. So here the same thing, it is divisible by 6. So 12 into something is divisible by 6, right? And the last one, 6 cube plus 5. So when a equals to 6 cube plus 5, we can say the first integer will be 6 cube plus 5, second integer will be 6 cube plus 6, and the last one will be 6 cube plus 7. So from here only in the middle term we can see here, this one we have taken out 6 as common. So we get 6 into something. So 6 into something if we get, the guarantee it is divisible by 6. So here we see that all are divisible by 6. So the logic in this question is, whatever the product we are getting, we have to write it in the form of 6 multiplied by something here, anything. So the same way, suppose we are having a number 24. Now 24 can be written as 6 multiplied by 4, or 18 can be written as 6 multiplied by 3. That shows that 24 is a multiple of 6 and 18 is a multiple of 6. Hence 18 is divisible by 6, 24 is divisible by 6. The same logic you are using here. Everywhere we are trying to get 6 into something. The something can be anywhere. So just you have to prove that whatever the product we are having, the product should be 6 multiplied by some factors. Hence product of three consecutive numbers is always divisible by 6.